Hello everyone, welcome to my chemistry channel BL the Short and Sweet in Chemistry. Now I am going to explain the hybridization in organic compounds. In part 1, I have explained the hybridization in methane. Now I am going to explain hybridization in ethane. Now it is one my heartiest request when you will read this hybridization in ethane, please read first the hybridization in methane, because methane and ethane both are interrelated for the hybridization. In methane also sp3 hybridization occurs, in ethane also sp3 hybridization occurs. Only difference is that methane one carbon atom is involved, whereas in ethane two carbon atoms involved. Now ethane, the structure is like this, cs3 and now cs3. That means here the cs3 undergoes sp3 hybridization, and this cs3 the carbon undergoes sp3 hybridization. That means see, both carbon are undergoing sp3 hybridization. Now here first you will see, as your methane, the configuration first you will see of carbon 1s2 2s2 p2, the same as you follow the that means of methane carbon. Here also ethane carbon also undergo the same process, fast electronic configuration. You know this is 6, this is 6, so 1s2 2s2 p2. Now what happened? This is called electronic configuration, and here ground state of carbon. When you see what are the states, what are the how the electrons are in orbitals s and p orbital. S is spherical symmetrical and p is having three orientation: px, py, pz. That means px, Py, Pz. And now in ground state, Pz is vacant. When Pz is vacant, then you will see how can you do the formation of the methane ethane like this. If only there are two unpaired electron, that means it would be divalent, because two unpaired electrons are the divalent, but actually no compounds that having carbon divalent, only tetravalent. That is why scientists, again it is done by the scientific excited state of carbon, they thought the carbon configuration, carbon orbitals px, py, pz, where pz is vacant. Now here this electron jumps to pz, that is why four unpaired electrons are there. You see 2s1 unpaired electron, px, py, pz. This is called excited state of carbon. Why? Because it would be divalent, but actually it is not divalent, it is tetravalent. That is why scientists developed the theory that is excited jumping of electron from the lower level to higher level. And that after that, the again scientists thought, if the compound is the structure of the compound is formed here, the orbitals what overlapping, s is lower energy, px, py, pz, they are generated means same energy. That means when px overlapping same, py, pz overlapping, that having same energy and same bond length like this. But when the 2s you know as having lower energy level, when this one overlapping, automatically the new energy and new that bond that having lower energy due to as having lower energy, which is not taking place in actually chemistry. In chemistry, it is proved that the bonds which are formed that having equivalent energy and length also same, then how is it possible? How is it possible? Why is it possible? Then the idea hybridization came. Hybridization I told in sp3 hybridization in carbon in methane. Here what happened, and here sp3 hybridization takes place as px, py, pz they overlap. Then what is hybridization? Intermixing of the orbitals having different energy and redistribution in a uniform way to the different orbitals have been called sp3 or sp2, like here sp3 orbital, and where the energy and when the bond is formed have the same bond length. That means here sp3 hybridization takes place by combining 2x 2s, sorry, 2s, 2px, 2py, 2pz. How many orbitals? 4 orbitals. S is lower energy level and px, py, pz having same level energy, that is called generate. And here what happened? sp3 degenerate. sp3 hybridization is known because s1 orbital, p3 orbitals, they combine, their energy combine, then again redistribution in equal level, in equal energy into 4 orbitals. How many orbitals are used here? Same orbitals, new orbitals form, same number of new orbitals form. Here sp3 hybridization, that is called sp3 hybrid orbital. Similarly in ethene, ethine, it is called sp2 sp orbitals. Then that one I will explain in the ethine and ethene. Now we will see hybridization in ethane. Now in hybridization, each carbon has sp3 hybridization as px, py, pz. Px, py, pz having same energy, whereas 2s is lower energy. They all combine and form new orbital. This is the structure you should remember. And each orbital has one electron. Then how many orbital? 4 orbital. But this is new one. This is the new one having same energy, and sp3 hybridal and is containing one electron. When it is overlapping with other, that forms bond and which having same energy as all 4 orbitals containing. Now we will proceed to how the carbon, 2 carbons, that is sp3 hybridization where takes place, how they form bond with 2 carbon and with 6 hydrogens. Now we will see how the bond formation takes place. I told in ethane there is sp3 hybridization in both carbons. How many carbons are there in ethane? 2 carbons. Each carbon is undergoing sp3 hybridization. So see how many hydrogen? 3 hydrogen. And this carbon sp3 hybridization. This carbon also sp3 hybridization. And here also 3 hydrogen. Then how the overlapping takes place between carbon and hydrogen, I want to show you. So now the carbon sp3 hybridization here explained like this, because there are 4 sp3 hybridals and here also the 4 sp3 hybrid orbitals. Now these two when come together and how they overlapping each other. See this orbital of this carbon and this carbon, they overlapping, head on head overlapping. I told head on head overlapping means sigma bond. Now here the head on head overlapping takes place between that sp3 hybrid orbital of this carbon and sp3 hybrid orbital of this carbon. Both undergoes overlapping, that is head on head overlapping, and form sigma bond, and so this bond is sigma bond. Now here you can find also the electron which is present in sp3 hybrid orbital. Here that overlaps with hydrogen. Then hydrogen contains what orbital? That is s orbital. You know s orbital is spherical symmetrical. So spherical symmetrical contain one electron and sp3 hybrid orbital carbon contain one electron. Both that is overlapping takes place. Then what is the name of overlapping? This overlapping is called sp3 s overlapping, and this overlapping is called sp3 sp3 because sp3 of this carbon and sp3 of this carbon overlapping. So the sigma bond which is known as sp3 overlapping. Similarly here how many hydrogen? 3 hydrogen this side, 3 hydrogen this side. They overlap, they means hydrogen, they overlap with sp3 orbital of carbon. So see here 1s of hydrogen. Similarly, in this side 3 hydrogen, that is s orbital, they overlaps, and this side also overlaps with hydrogen, and that overlapping takes between hydrogen and sp3 carbon. So this side 3 are bonds, and this side also 3 bonds. In middle carbon carbon. So all are sigma bond. This also form sigma bond. How the sigma bond is formed? Head on head overlap, like this. Head on head overlapping. Here this is sigma bond, this is sigma. Similarly, all the 6 bonds which are formed between sp3 carbon and s of hydrogen, they are sigma. Similarly, sp3 of carbon and this sp3 of carbon, so they also form sigma bond. Now you can see here, first I have shown you this is the sigma bond sp3, and now here it indicating that how the overlapping takes place here. Here also one, here also one. Simply I want to explain because here it looks maybe complicated. So here 6 bonds form like this, and they are known as sp3s overlapping. This is also sp3 overlapping sp3s. And now middle age sp3 overlapping, all are sigma bond, but 6 carbon hydrogen are same, and one is carbon carbon, that is different. And so this is the structure. I hope it is clear. Here both carbon undergoing that is sp3 hybridization, and 4 this side 3, this side is 6 hydrogen atoms, sorry, 6 hydrogen atoms here overlapping takes place between sp3 carbon and 1s of hydrogen, which also form sigma bond. Now this is the main explanation of ethane structure, which undergoes sp3 hybridization. In sp3 hybridization, 2 examples, most important examples are there, sp3 and sp3 undergoes, that is one is methane, other one is ethane. Both are having sp3 hybridization. I hope it is clear to you, and hope you will subscribe my channel BL Das Short and Sweet in Chemistry. In coming video, I will explain ethane, how ethene and ethane. Ethane is finished, methane finished. Now we will go to ethane and ethene, and next we will see what are the possible structures of methane, what are the structures, 3D structure, tetrahedral structure, 2D structure, 2D structures we will observe. So next coming video I will explain ethene and ethane, where what are the type of hybridization takes place. Thank you all for watching my video. Thanks again to all.